Hello and welcome to topic 6 in the series on artificial intelligence. And today we'll be talking about logical agents. So that's not necessarily a federal bureau in our government anyway. But anyway, a logical agent, and the basic idea is that you have agents that respond in very kind of predefined ways. And so sometimes these agents can be fairly successful just almost by accident, if you will. So to reflex agents finding their way from relatively large distances, just basically getting lucky. A chess program that knows how to calculate all kinds of legal moves, but doesn't know that two pieces can't be on the same square at the same time. Sometimes we need to make sure that our agents know a bit more about what's going on than we might realize that they need to. So moving on, knowledge-based agents. So the basic idea is, as we've talked about before, you have a kind of a environment, a world, and whenever we're dealing with it in this situation, we introduce the concept of a knowledge base. And a knowledge base is a collection of domain-specific content, so knowledge about a thing, a collection of things. In particular, around some more specific environment, if you will, or purpose. So you may have some independent domain algorithms, or domain independent algorithms, so things like inference engines and so on that may be able to do inference across all kinds of domains. But when you want to apply them intelligently, you want to make sure that you're utilizing a knowledge base, which is a set of essentially sentences represent knowledge about the world in a knowledge representation language of some sort. And an inference rule is if you asked a question of the knowledge base, the answer should follow from what has been told it or told to the knowledge base previously. And this is using very specific terminology as far as asking and telling of knowledge bases from the inference engine. We talk about a generic knowledge-based agent. It's something that returns an action that basically starts off over some period of time t that generally speaking is the indication time. And it's utilizing this knowledge base sort of tell an ask sort of sequence, right? So that's the basic idea of a knowledge-based agent. So when we talk about agents, they have to be able to do a certain set of functionality to be really very viable. They need to be able to represent states and actions, be able to incorporate new percepts. So you learn something new, maybe it's totally novel that hasn't been encountered before, that you need to be able to represent in some fashion. Also, you need ability to update the internal representation of the world as you learn more about it, and potentially do some form of deduction around hidden properties of the world, and then figure out what are appropriate actions to take in this world that you're learning about. A knowledge-based agent is like agents with internal states and then some, right? They can be described at different levels. A knowledge level is what they know regardless of the actual implications, so a declarative description, and then implementation level, data structures in the knowledge base and algorithms that manipulate them via something like propositional logic or whatever to reach ideally some sort of resolution. One of the examples that you may run into in the AI world is Wampus World. This comes from an old, used to be command line sort of game where it was all text-based. You played by trying to navigate through a maze, and it basically doesn't tell you too much other than whenever you get near certain things, you learn, right? If you're close to the hazards, so if you're close to a bottomless pit, you'll feel a breeze. if you're near a colony of bats, you'll hear flapping nearby, and so on. So, and then you can smell the wampus because it apparently doesn't bathe often. Um, a wampus is heavy, so bats can't lift it. So these are basically the rules of the world, right? And what you're doing here is that navigating through this world by basically just moving in a direction, or you may choose to shoot. You only have so many arrows, is the thing, and um, you the variation is going to be a question of if the wampus moves or not, right? So the basic idea is you either you die or you get a bunch of gold. So not a very in between sort of result. It's either one of the extreme or the other. And once you're in the environment, you'll come out either winning one of those, either winning or losing. Um, so the squares adjacent to the wampus are smelly, so you can see whenever the fog of war is rolled back, so you have a perfect vision. You can see where stench is. You can also see that there you can have both stench and a breeze and some gold all in the same cell, right? So in cell 3-2 there, you've got all three of those things stacked up on top of each other. Um, you um, also have this idea of glitter if you're near gold and a few other things. So lets you kind of get some sense of it. And you basically have actuators, turn left, right, go forward, grab, release, or shoot. So pretty interesting world. Was pretty compelling at the time somebody wrote it way back when. Now more so of from an academic perspective, and people have spent a fair amount of time on this sort of stuff as well. Part of the reason is not because Wumpus is such a compelling game, but because it is a relatively easy to understand set of rules and an environment. So the questions that you ask, is it observable, and no, only the local perception. Is it deterministic? So yes, the outcomes are exactly specified, dependent upon obviously what the player does. Episodic? No, it's a sequential at the level of actions. And then, yes, it's static because the Wumpus and pits don't move. So it could be a variation of the game where it might. Is it multi-agent? You can think of it, yes, it is, because the Wumpus is kind of similar to another agent, although it's not moving and really interacting with its world, so maybe not. When we explore the world, these are essentially the things that we know as we go along. And so, given the fact that you know that you're near things from various locations, you might have the ability to be able to detect them and either navigate around them, or, in the case of the Wumpus, shoot it. And so that's the basic idea. So logic, what is logic? We use it all the time. It's into popular culture. That's illogical. Um, and so on. And it's probably not what you think it is. It is a formal language. There's a formal syntax. It also there's a series of expressions that are either well formed or not. So there are syntactical errors. There are semantics of what is a legal expression, what does it mean, and then it's somewhat similar in some regards, you might say, to some of the languages of arithmetic, right? When we have something, one thing follows from another one. It can be expressed in this way. KB entails the sentence alpha, if and only if alpha is true in worlds where KB is true. So it's some very specific sort of words. And it's almost saying kind of the same thing as x plus y equals 4 is also means that y or 4 is equal to x plus y. So kind of just switching things around. Entailment is a relationship between sentences that is based upon semantics. So they could have a characteristics where they're involved with each other. A model, we talk about models all the time in AI. It's typically a formal structure that is used to represent something which is much more complex. It's, at the end of it all, that's what it really is. And M is a model of a sentence alpha if alpha is true, and M. And so on. So you have some serious ways of how you define explicitly these things, these words, and what they mean. In the situation where we're talking about the WAMPUS model world, we kind of have some things like knowing where the player may be, and what things that they have learned as a possibility. And whenever you are encountering something, there are some variations that are possible whenever you're doing it. So what you would do is potentially apply the same sort of concepts we've applied before in things like search and so on, to try to minimize risk or maximize return, some sort of set of characteristics. So a basic idea of being able to combine together your knowledge, use your observations to increase that knowledge, and then hopefully find and kill the WAMPUS. We talk about logical inference. It's the notion of entailment that can be used to do essentially logical inference. So whenever you have a model, you can check the model by enumerating all the possible models and check whether or not essentially alpha is true. If an algorithm only derives entailment sentences, it is called sound or truth preserving. So it is a sound model or a truth preserving model. Otherwise, it's just making things up, right? So the basic idea is that you want models which are truth preserving and that are sound and also ideally complete. The algorithm can derive any sentence that is entailed. Right? So some very specific sort of words that kind of make sense intuitively to us most of the time, but sometimes we need formalized language to address this stuff as well. So from a semantic perspective, we have the representation of the world. So representation on one side, the world on the other side. And we're essentially capturing some aspect of the world via sentences that are following some sort of semantics. So the basic idea is that the KB is true in the real world, then any sentence alpha derived from KB by a sound inference procedure is also true. So that's the key word there is by a sound inference, right? So a truth preserving inference model. And with that, if you have any questions about the material, let me know. We'll be continuing to work through these topics related to AI. I try to keep them shorter if I can. Some of the stuff is harder to keep it short. I try not to make it towards a tedious thing to go through. Let me know if it's helping. If any questions, feedback, feel free. I'll talk with you later.